take a look at identifying similar triangles. Now, there's three methods for identifying similar triangles. There's angle, angle, there's side, angle, side for similarity, and side, side, side for similarity. Now, angle, angle, we've already talked a bit about. As long as you can show that two angles are congruent in the two different triangles, that's enough information for us to say that they are similar. Now, just a reminder about naming conventions with our identifying what those similar triangles are. One thing we have to make sure is, since we know like angle A is congruent to angle E, when we're naming it, since we're starting with angle A for the first triangle, angle E has to be the first letter, right? We have to show those corresponding sides. So the name of our triangles has to match with their corresponding sides. So triangle ABC, that means E, F, and G angles are all going to be congruent to the A, B, and C angles of the corresponding triangle. Now let's take a look at a couple other examples. So side, angle, side for similarity. Now we're not showing that the sides are congruent, but we're showing that they're in proportion. Now could that mean that they're congruent? Yeah, but it really then that's taking us the next step, saying that they're congruent and not just similar triangles. But what we're really going to be looking for is a pair of angles that are congruent, and then the two angles surrounding them, the two sides surrounding them being in proportion. So for instance, a quick example of this, if I put some numbers on this diagram, let's say this side was 2, EG is 2, AB is 4, EF is 3, and that means AC is 6. If I were to set up the proportion matching those sides, we would see that they have the same ratios. So I could say 4 over 2 equals 6 over 3, which, since these are the same, right, when we reduce these, we get the same value. We know that these sides are in proportion, right? So the sides are in proportion. Since they're in proportion and we have that matching angle in between, we could say that these triangles are similar by side, angle, side similarity. Now, side, side, side similarity is the same thing. We're just dealing with all of the sides, right? All three sides have to have that same matching proportion. So again, I'm just going to pick up a couple random numbers here to kind of show that proportion. But let's say we have EF is 3, AB, let's say, is 9, FG is 5. So that means the matching side BC will be 15. I'm going to make EG 4, and then that means AC will be 12. So just picking some matching sides. These are actually sides of our right triangle. This doesn't look like that right triangle, but we're just looking at those proportions here. So I know that if AB, right, the ratio of AB to its corresponding side, FE, has to be the same as BC to its corresponding side, FG, and it has to be the same as AC to its corresponding side, GE. So really, ideally, if the numbers aren't as recognizable, you could type these into the calculator, but we know 9 over 3 is 3, 15 over 5 is 3, and 12 over 4 is 3. So we know, again, the sides are in proportion, so that these triangles are similar. And in this case, it's by side, 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 instead of side, angle, side. All right, so those are our three reasons. What you guys are going to need to do and start doing is, before we set up proportions, make sure that these triangles are similar. So some cases that's going to be pretty straightforward. Some cases that might be a little bit more difficult. So we're going to take a look at this first one here. Our goal is to determine if the two triangles in each example are similar to one another. So our two triangles we have here, we have MFG, and we also have MKL, right, the larger triangle here. Now, when we look at this, we know angle MFG is congruent to angle MKL, and that's simply because they're stating that for us. They're telling us, hey, they're both 54 degrees. Now, to find our second angle here, we can actually use the reflexive property up here. We know that angle M is congruent to angle M because of that reflexive property. And since and since that's two angles, we know that triangle MFG is similar to triangle MKL because of angle. All right, when we take a look at letter B, Similar question, right? We have these overlapping triangles here. So in this case, I have this smaller triangle here, HGI, and then I also have this larger triangle here, HFE. And our goal is to prove that they're similar if we can. So in our case here, we know that there's that reflexive angle. So I know angle H is congruent to angle H because of that reflexive property. So we already know we have an angle, but everything else given to us is dealing with sides. So our next goal is to see if those sides that are attached to the angles are in proportion. So I'm going to take for each of these triangles, remember we have kind of like this smaller triangle that has sides 16 and 25, and then we have this larger triangle that has sides 75 and 48. So we're going to set up that proportion of sides here. We're going to say, okay, well, let's say we have 16 over its matching side 48. We want to see if that's equal to 25 over 75. Now, 16 times 3 gets you that 48, so this can actually reduce to 1/3. And same thing with 25 and 75. This 25 times 3 gets you. So we do know that these sides are in proportion. So since these sides are in proportion, we're able to say that these two triangles are congruent. I'm sorry, similar. We have triangle HGI is similar to triangle HFE because of side, angle, side for similarity. All right, two more questions, two more examples, and then I'll get you some practice on this. So part C, similar situation here, but here's the problem. We don't know anything about the angles. We only know information about two of the sides, and we're not, so we actually, in this case here, in this example, there's not enough info. So we're going to say, hey, we don't know if these things are similar, not enough info. Now, if we had something like these two angles were congruent, that would help us get the ball rolling, and then we could check the proportions. But since that's not given information, we can't assume that information. All right, now take a look at D. When we're working with D, we have two triangles with all three sides on each. So our job is to match those corresponding sides. Now, if you're having a little bit of trouble figuring out which ones, it's really like the smallest sides, the sides in the middle, and the biggest sides together. So for instance, here's our two smaller sides. So we're going to have to set up a proportion that will be the two smaller sides. So I'm going to say 5 over 30. We have to do the same thing with maybe sometimes it's easier to go to the largest sides after that. So I have the 8 and the 48. So I want to see if I put 8 over 48. And then I'll do the same thing finally with that last sides here. This would be like our middle sides here. We're going to say 6 over 36. And when we check these fractions, when we reduce them, these all become 1/6. So we know again, these sides are in proportion. And we could say that these two triangles are similar. So triangle XYZ is similar to triangle EFQ because of side, side, side for similarity. So there's a little more practice for you guys after this. Let me know if there's any questions.